Hi, this is Steve Barton. Today we have a project from one of our subscribers and viewers, Dave Myers from Effenberg Knives. He makes some CNC folder knives. This is a store-bought Gerber. It works out nice for me, but he makes folder knives like so. And but they're a lot higher quality than this. I'll put a link in the comment section to his site. As I said, he does these knives on CNC equipment, and he's going to be making a fixturing system where he can load these like mini pallets with his knife blades on the CNC equipment. He bought some of these bushings, and they had bullet nose. This isn't the dowel pin that goes with it, but they had a bullet nose dowel pin. They're supposed to be a high precision locating unit because the plates he's using is aluminum, and he explains in his video that if these plates go in their location in and out, well, the aluminum, if anybody that works in it knows it doesn't wear very well. So you got these hardened bushings and pin sets that you can put on these plates. They're used for locations, and he's wanting me to true the ID, the internal diameter. He's wanting me to get it a little bit truer than the OD. A lot of times these bushings, they come in, I think they're spec'd out at plus or minus 3/10,000ths of an inch on concentricity. In my experience, I found them out over 1,000ths of an inch already. So I told him that we would grind these up a little bit and get them more accurate for him. And so this is what the video will be about today. If we get time, we'll go over one of the viewers was asking about the actual grind on the boring bars that we made on the hardened center drill that you have on there. So we got a chance, we'll cover that. But in order, oh, and then we had another viewer that wanted to know on the quill, how you work with the automatic quill on the mill. And so we're going to try to cover three things today. If you watch our last video when we were making a boring bar similar to this one, you saw that I made a mistake, scrapped one out. But like any good tool maker, there's really never scrap. It's just a different project. And on this one, we cut this off, and what I'll be doing is I'll grind. Actually, I'll mill this diameter first so I can demonstrate the quill feeds. We'll mill that down, and then we'll set it up in this fixture like so. Get our indicated in real good. We'll grind it down real nice, and we'll get it so that we got a good fit on these bushings. Now, I went through with these bushings already with just a simple dowel pin, and I could feel there's just a slight difference. And so what I did, I went through and I got the largest diameter up here, smallest diameter down here. And to give you an idea of the feel that I can feel, now we're talking only a couple 10,000ths of an inch. But if you've done this kind of work in the past, you get good at it, you can feel a lot. You'd be amazed at how accurate you can be with just the feel of things. So basically, I got the smallest diameter here, the largest diameter there, and again, it's only by a couple tenths. We're going to grind this diameter here, starting at the biggest diameter, and we're going to grind this diameter so it's just a real nice fit. And we're going to use just a little ink marker on the shaft to act as kind of glue to grind it. And so it'll be kind of something that'll be interesting, something might be new for some of you guys. So what we're going to do first, we're going to go to the mill. I already got it set up, and we're going to demonstrate. And this was for a Russell Thornton. He asked to see how the quill worked on the mill, and we'll go over that on the automatic feed. Okay. Basically, I have this set up already, so I'm going to just stick it in, tighten it up. I don't have the three-phase generator on yet, but I'll just go over the automatic feed on the quill here. this knob right here, when you swing it from this click 180 degrees, I'd have to have it on to get the gears engaged. What that does, that engages all the gear mechanisms to give you your automatic feed. And if you come over on this side, you have this you pull the lever out and you have these little spot holes in there, and you can swing that down and that will determine the feed rate. And so if I'm sitting at the top, for every revolution that this spindle is turning, it's feeding down 3/1000ths of an inch. If I go to this setting, for every revolution that we have, I'm going down 1/1000th and a half. And if you go to this setting down here, for every revolution that I turn, I'm going to go down 6/1000ths. Now, the last video you saw I was bird nesting a little bit, but I was cutting a smaller diameter. I was cutting at a 3/1000ths of rev. To get rid of the bird nest, a lot of times you can go to a higher feed, but with a smaller diameter, sometimes you get a lot more push off. I'm just going to cut this at the 3/1000ths per rev, and I'm going to cut this diameter down, leaving about 5/1000ths grind stock that will true up on the grinder. I did change my insert, so I got a nice sharp insert. Last week I could tell it was getting a little dull, and you can get quite a long stick out on these if you got a good insert, good and sharp. Use positive geometry, small radius. I got a 15/1000ths radius. And one of the things that you want to do in a setup like this, if you go with a negative insert, you're going to generate a lot of cutting pressure. You're going to end up with a lot of taper on your part. If you have a large radius of 30 or bigger, you got more pressure touching on the side, and it's going to push off. So going with a positive geometry on the insert, going with like a 15/1000ths radius, and taking light cuts at the end, you can cut some pretty good diameters here on the mill. And what I did with the boring bar last week, I ended up with about a 7/8 taper on the final boring bar that I had. I just took off camera a little piece of sandpaper and sanded it in and had it all within a couple tenths in just a few minutes. So jobs like that, that's an easy thing to do. I'm going to turn the 3-phase converter on, and then we'll come back and we'll cut on here. I already have it preset on my location, so we'll be good to go. I need to set this to my step here first. The noise you hear in that is the power feed nuts not lining up straight, and sometimes you saw me with hitting that while it's on, sometimes that'll straighten it out so you don't get that. It's being a little stubborn now that we're on camera. So right now I'm just going to set my stops up. I'm going to come up to the shoulder here, touch off on there. Again, we'll use this. Now you see that this engaged all the mechanism. This other dial we're set at 3,000 per rev, that set our feed rate. And now what we have over here, this is spinning in this direction, and because I'm going in the forward direction, as I go down, if I click this lever, it will pull the quill down automatically. If I get all the way up up to my stop, I can pull this out and you can see it reverses. And then what you can do is you can pull your quill. Now I always put some back pressure on there, and sometimes I lock this not tight, just snug, because what happens, there's a heavy spring in here and it will pull up and skip, and so you want to put a little back pressure on there. This also, if you go in the middle and you want to stop the mechanism, it's neutral. So in, it'll feed down, and forward gear, if you're in reverse, it's going to go just the opposite. Pull that all the way out, and then this reverses, and then it will reverse your direction of your cut that way. So push in, get close to the cut. You're just putting a little bit of pressure on there. This direction's not as critical as when I reverse it. This is set up on the stop so that when I hit that shoulder, this will automatically click in, and when it clicks in, it will stop the feed. Now to reverse it, I pull that out, pull that down, and then I hold a little pressure just so the spring doesn't override the gears and pull up on them. We get to this point, we'll check the diameter. And we're 499 6/10. We want to cut this down to about 318. Be about a 75 thousandths total cut, and that's kind of pushing it for a small diameter. And I'm just curious to see if it'll work. Normally I would have my shield up, but then I want you to be able to see what we're doing. Really, you only have to do your blank pass on your semi-finished and finished cuts, and hopefully this will be a semi-finish here. If I got things figured out right, I have about 10,000 stock on where I want to be. I'm going to cool it off right now. It does generate heat. Actually about 20,000 stock, and we're 337 and 7/10, 337 and 7/10, so with a good sharp point on there, and short stick out, we're doing pretty good. We're going to try to cut half of that off, sneak up on it a little bit. Should have have about 10 thousandths to go after this cut. .328.7, 328.7. Should be our last cut. About 320 and 4/10, 319.9. I'm going to go ahead and take it just a little bit closer so I don't have as much to grind. When you reverse this, sometimes you got to hold it a little bit if you're at a stop till it engages and goes. If you don't hold it out a little bit, it doesn't let it lock in. But once you get started, you should be good to go. .317.4, 316.8, 316.9. We're good. We'll grind the taper out. I'm going to just turn this on, break that edge. One other thing I'm going to do, I'm going to clean that shoulder up nice. I'm going to wind up a couple more thou. And we'll hit this shoulder a little bit. I'll grab a smaller file. Okay, let's bring it to our spin fixture, get it set up, and we'll grind that diameter down.